Now, what I'm really interested in hearing from all of you is certainly questions, and we'll be happy to answer any questions. But what I'm really interested in also hearing is your experience and some feedback from you on some areas, use cases that this might apply to in your own personal experience that you've run across. And certainly, we're open to answer any questions you might have.
Actually, I'll jump in here, Vivek, because I've actually been talking to a few of the wireless people that I know in the background. One thing that has me curious. So you guys are doing some advanced beam steering in these devices. Is there any kind of centralized control system that allows this all to work together, or is all the intelligence built into the units themselves?
Okay, so there are two ways to answer that. There are two answers to that question. The intelligence is built into the units themselves. Most of the intelligence, that is definitely true. And when we first start out with our first MVP, our first product, you can basically think about this. You might want to just move closer. As completely units themselves, a decentralized system. It's a self-organizing Ethernet network that each unit does what it has to do to create this ring, and then does what it has to do to find the shortest path through the ring. And the beam steering is entirely controlled by these decentralized devices. However, in the future, as we develop more and more advanced network management solutions, I could see optimization on this network in terms of finding where the traffic is the highest and so on, and finding where to route this traffic and how to route this traffic and how to connect to the next node. So there could be possibilities of that in the future, but right now it's all decentralized. Each unit does its own thing.
All right, thank you. One question that did come in from Twitter from our friend Richard McIntosh. He wants to know, are there any backup radios for failover purposes in the unit, say maybe in 5 gigahertz or even in 2.4 gigahertz? Or is this 6 gigahertz only, and you're not anticipating getting any kind of interference from any other sources?
Okay, there were several questions there, so let me try to answer them, different questions. So first, let's talk about interference. So as I showed you in the diagram before, this system, you cannot interfere with it because the side lobe, at least at 60 gigahertz, you can't interfere with it, and 5 gigahertz you certainly can't interfere with it. So because of at 60 gigahertz, you can't interfere because of the side lobes and because of the fundamental capacity of 60 gigahertz. It doesn't go very far. So as you go further down the path, it's difficult to interfere. So you can reuse spectrum a lot. So interference is not an easy. You can't interfere with the system easily. In terms of backup radios, we don't have any backup radios, no 5 gigahertz radios here. We have two 60 gigahertz radios, however, in each unit. And so in a way, they could back up each other because they're all connected in a ring. If one radio fails, you can still use the other radio to send data around the ring. Dave, what do you think? Any add-on to that?
Yeah, the idea is the beams will be mounted high enough that you won't have physical interference, and you won't have interference from any other 60 gig devices, since our EIRP level is pretty high in the system, and you'd almost have to be right in the beam path to interfere with it.
All right, and that makes sense. And I guess that by mounting them high up on the thing, as Vivek's presentation said, that's going to cut down on things getting in the beam path to cut down on those kinds of things, right?
That's correct.
Okay.
So I've got a question relating to that ring. Is it purely a failover ring, or when everything's up and running, are you maximizing the bandwidth by using both paths?
Answer is both. So it serves a failover purpose, but when there's no failure, we're going to use both ends of the ring to maximize the throughput.
Okay, thank you.
I've got two questions. First one is impact on people. There are going to be concerns about that. Could you address that point? And then the second one is, I've been sitting here thinking, I think I answered my own question, that is that enough access speed, basically? And I can see desktops at most firms being quite happy with 1 gig for most office environments. I've got an exceptional customer that's probably moving to 6 times 25 gig to the desktop, but they're doing game development. So explains itself. So I guess the real question is people putting plants and blocking the beam, stuff like that. Are there any concerns or things you have to anticipate having to deal with on those fronts?
Yeah, the beam is so focused. I mean, unless you had the plant or the object, right at the ceiling level, there's not going to be a problem. But, the Fresnel zones are small on these beams too, so that's not going to be a problem. It's also safe. We'll operate within the FCC safety limits, which fundamentally an average of 40 dBm EIRP, which equates to their standard of 2 meters from the PA source, and the field has to be at a certain level. So there's no problem with safety in it also.
Yeah, I'm envisioning somebody doing something really stupid, like climbing on top of a filing cabinet for some obscure reason to hang up Christmas decorations. I don't know. So I figured it.
One thing that I have to mention about that is, it is kind of a new way of doing things. So anytime there's a new way of doing things, you got to get used to it, right? So, but then once it becomes ubiquitous, then you naturally model your behavior around that new way. So just like wireless became ubiquitous in the enterprise by using Wi-Fi, before it was all wired Ethernet, there are going to be changes in behavior to accommodate that, as long as it adds value to what we're doing. Certainly this does. So, yeah.
Actually, can I add something to that?
Sure.
So actually, the maximum power that we are sending, so the average power that we are sending is 10 milliwatts. So even if you put your head against this thing, I think it's a small fraction of what you get when your cell phone is initiating a call. So because the average EIRP is 40 dBm, the maximum is 43 dBm. Our antenna has around 30 dBi of gain. So that basically means that we are sending 10, that's a nominal value, to 13 dBm of power. And that basically is 10 to 50 milliwatt of power. So I don't think that even if you are very close to it, to hang something on your Christmas tree, it's going to cause any problem. The absolute power is very low. So that 40 dBm is EIRP when you are away from it. Like you need to be like 1.5 meters to 2 meters away from the panel, from the antenna, to have that. When you get very close to the near field, there is no beam shaping, and you basically just absorb 10 milliwatt of power, let's say to 50 milliwatt at peaks, which I don't think it's going to cause any damage as far as I know.
So you got a theoretical maximum of roughly 7 gigabit on .11 AD. How close are you guys getting to that on your backbone?
We are actually there. I mean, we are constrained by the chipset, if anything, because we certainly are all other aspects of the system are performing better than that. So we only went with the chipset because we want to get the product out quickly, and we expect that the capacity of 6 gigabits maximum throughput is more than adequate for most initial applications. Ultimately, though, our design accommodates a much higher data rate. All other elements of the design are much higher data rate. So we are actually exceeding the maximum capacity of the chipset. I mean, our design does, but a chipset is what limits us.
Right. So we can expect roughly 6 right out of the gate, more later as it develops.
Correct.
That is very cool. Thank you.
So we had a follow-up question about how thick a material have you experimented with, which I guess is an inevitable question, like how thick a material can it penetrate? One of our bearded Wi-Fi colleagues says he has a mansion with 4 foot thick concrete walls that have been quite a challenge. So there you go. The gauntlet's been dropped. How do you feel about it?
Yes, we've experimented with going through bricks. It does fine going through bricks. We've standard building bricks that we have here, ample amounts of wood, glass with wire mesh. Because of 60 gigahertz, even if the wire mesh is half inch or thereabouts, it doesn't present any obstacle to the 60 gig. So we're still improving antenna design so that we can get through larger amounts of concrete and cinder, cavity cinder block.
Would it be okay to assume that if they're metal walls, that's a problem? I've run into government contractor buildings where they've got movable partitions that are actually metal coated foam or something like that.
Metal objects. You can have drywall with metal, aluminum studs. They don't occupy, the full density, across the wall. So they're okay, even if they're 16-inch spacing typically here. Metal walls, obviously, they're not going to go through that.
Yeah, and the 4 feet concrete, we won't go through either. Just saying.
Well, but we have this near field operation as well. So that's the other option that we have for thicker walls with 50 dB of attenuation.
Yeah.
So how many of the WaveTunnel devices can you put into a single ring? I'm thinking, I used to work for a manufacturing company, large open spaces that would have things like rubber and stuff like that in there. So obviously that's a problem for signal. But if you have more devices, you can get around that.
Right. There's no limit to the number of wave tunnels in a ring, because each wave tunnel really talks to 2 neighboring wave tunnels. So there's no real limit. Of course, the only limiting factor is if you have to, if a part of the ring dies and you have to go all the way around the ring, and the ring is a very large ring, then there's more latency involved. But otherwise, the software will find the closest path to go from point A to point B. It'll go one way around the ring if that's closer, the other way around the ring if it's closer. So, but there's no inherent limit to the number of wave tunnels that you can put in the ring, because these wave tunnels only talk to the neighboring guys.
And on that note,
that suggests another design, which could you do multiple rings going back to a central switch?
Yes, we can.
So on that note, in your software, do you have a way for alerting like this part of the ring's failed, and that way you don't have to go search to find the failed device? Of course.
Absolutely. And the software will be able to monitor every element of the ring, traffic through each node, all of the traditional, monitoring elements. Monitoring will be done by the software, and it will tell us exactly which node failed and how's the ring operating now. Yes.
I have 2 questions. I'm looking at this and I'm thinking, like, this is a great opportunity. Like, I know my small company is looking to build out a new office space, and so we've been, getting some prices for what it costs to run cable, and this is just standard office, running cables back to a patch panel somewhere and getting everything ready. It would be great if we could just go around after the walls are put up and just start slapping these up around the office. Where do you guys see the price point for something like this? I mean, is it something that a small or medium-sized business can consider buying instead of running cables throughout their offices?
So we did an analysis, right? Our cost analysis, and now it depends on the configuration of the box, of course, but we're talking about in the range of $800 to $1,000 for a particular box. And we did the analysis of putting those boxes up, the number of boxes you would need for a particular amount of square feet. And we said it would be at least a third the cost of the overall cost, including the labor, would be about a third of cost of putting a cable in. But the speed is much greater. I mean, the ease of installation, putting that system up, of course, is hours, not days or weeks. So you get advantages both in time and in cost.
Yeah, and then the other question I have is what is the protocol that's carrying our data between the units? Are you just sending Ethernet across that, or is it some sort of tunneling mechanism or something else?
So initially, the first product will be 802 or 11AD. The package will look like, essentially it's running our 802 or 11AD system. Ours ultimately will be native Ethernet. So the protocol will be Ethernet, but directly on the ring.
Wow. Okay. All right. Thank you.
Sure.
And what about security? Are the data encrypted with any standard protocol, or you have your own?
So it will be encrypted. It will be encrypted with all the layer 2. We have a full layer 2 switch. Each of these boxes, think about it as a layer 2 switch. So all of the encryption that's available for layer 2, we can do. So it'll be fully encrypted data.
A question, maybe I missed it earlier in the presentation, but what about not through walls? What's the open space distance we're talking about?
Okay, so open space, we are designing this for 100 meters indoors.
100 meters.
Right, between 2 nodes. And we've tested it at that, and it works at 100 meters.
So essentially matching the wired distances that we're used to.
Mm-hmm.
So you just mentioned indoors. So is there any outdoor application? Have you been planning for that, or is that not on the radar?
So we are planning to have outdoor applications. Now, COVID has thrown up on all kinds of opportunities where you're extending the network outdoors. But it's not like, it's not going to be used for, we don't intend to have this used for a purely outdoor application. However, where there's an outdoor extension from inside, like to the parking lot or to a tent in the hospital parking lot where you can do testing, or to a outdoor facility outside of university buildings, things like that, we can penetrate the exterior wall and take it outdoors. And we have been looking at, for example, applications where school systems use their internet capability that's coming into the building, where there's nobody in the building, and sending it outside the building, and then we can penetrate the exterior walls, and then another product picks it up and broadcasts it using wireless backhaul to the neighboring communities. We've seen applications like that. If you're getting access to libraries and you want to sit in the parking lot, we can penetrate the outdoor wall, the exterior wall. In addition, if there's a campus environment where you have buildings relatively close to each other within a campus, and you want to shoot this beam through the glass windows from one building to another, you can see that as well. So the combination of mostly indoors with some outdoor extensions is where we intend to deploy a product. But in terms of a pure outdoor application, there are many products out there already doing that. And so we didn't want to enter that space. It's a pretty crowded space.
Sure, that makes sense. So I mean, I think the natural question from that then is, you've tested against indoor building materials. Have we tested against, outdoor weather type obstructions? I mean, rain and fog and those types of things tend to have negative implications for outdoor, traditional wireless. And so I don't know, is your, is the beam forming and the stuff you've done with the antennas and gain overcome those obstacles as well, or is there still considerations there?
Well, because of the antenna gain, any attenuation is better overcome. And maybe Ehsan, why don't you tackle this question?
Sure. So basically, what is happening is, because we have a higher gain, and because this is point to point with like a very tight and narrow beam, we have a higher link margin. So of course, if you are at the limits of this system, the 2 units are at 100-meter distance and everything is running at capacity, and you have rain in between or something like that, that's going to cause some problem. However, you could always lower the data rate or have the units closer together. When it comes to rain and fog, we have done, actually not specifically for the main product, but we have done a lot of simulations on the effect of rain and fog and other like dust and so on how much loss you have over 30-meter distance, which is basically the closer when the panels are closer together, and it's going to basically add loss. But I think even a heavy rain, it's not going to kill the link completely if you have two of these units at around 30 meters away from each other. But as Vivek said, we are mostly focused on indoor applications. So
yeah, I appreciate that. I figured I'd ask the question since there are some potential applications, and I could definitely see people wanting to use this outdoors. I understand the start where you start. You guys are, like 30 minutes out of stealth now, so I can appreciate that not every use case is there, but I think that it's good to know, because I think that people will do exactly what you just said. Can I extend this between buildings? Can I, and so, yeah, I mean, the attenuation's still there. That's what I heard, but because of the narrow focus, the margins are a bit better.
Correct.
Exactly.
And that allows us to penetrate exterior walls. We do have to, of course, complete some testing on if a use case comes to us with a different type of material. We'd have to do some testing there. We've got to optimize the system for that. But at this point, we are envisioning that this will be an indoor application with an extension to outdoor. There will be use cases like that. We're envisioning that those use cases can be satisfied with this product.
I've got a question in the form of a war story, short war story with optical technology like lasers. We have a customer that suffered seagull attenuation and outage. And then the second one was a customer in New York, buildings across the street shining through glass, and they suffered window cleaner attenuation. Luckily, the window cleaner was not blinded. So that has me thinking about what would sort of defeat a building-to-building application. And maybe we don't need to worry about that now because that's kind of down the road, corner case and so on. But
well, this as Ehsan pointed out, our power is pretty limited. It's not going to harm anybody. So unlike a laser, if you look at it, or something. But So this should be okay for building to building applications. I don't think those particular issues will arise.
I was thinking the other way, rather than harm. What could bring it down or defeat the product?
Yeah.
Dave, you want to tackle?
Well, if you had objects, that could occasionally be in the way of moving objects, like you say, the building cleaner, in scenarios like that, you typically just put up dual links and, you'll switch between the two links, right? There'll be an automatic switch over. It'll pick the best path. So it's a spatial diversity technique that would be in the traditional microwave world. You would just apply that to this if you had a concern about somehow the link being down for whatever reason, something.
And maybe you post a sign saying, "Do not park a truck in front of this," or whatever.
Right. Yeah, when you're loaded to the street, that always becomes a problem. They mount a lot of millimeter wave radios, in the street levels, and when the tall trucks come by, that could be a problem. So you would like to put up two links and have it, have a little diversity there, so they can't block both of them at the same time.
I think another thing that could cause a problem is Spider-Man. If you have people that walk on the ceiling, that's going to cause problem.
We'll just bring 2 trucks. It'll be all right. Have you guys, by any chance, we were talking about other uses, tried firing them through a floor to go between 2 different floors? And I realize we're shooting through concrete again, but maybe a bit less than the 4 feet we were talking about earlier.
Right, that's a very good point. And we have not done testing there, but it's something that we will be doing. And as Asan pointed out, we know we can get through concrete, attenuation, high attenuation through different techniques, but getting through floors or figuring out through how to get from floor to floor, that's going to be definitely some use cases will arise that will require that. So that testing, we will do that testing, and we've got to find the optimum way of getting through floors in many cases. So, I mean, ideally, this is like within a floor, it does really well. And going through floors, we have to do some more testing and validate that.
Yeah, I can definitely see the product as being, kind of look at it as like a physical overlay network in some ways, which is where, if you're not running the cables yourself, or you want to avoid running the cables, you can go in somewhere and say, I want to run my own network in this place. Where do I want to put stuff? And whether you're in somewhere temporarily or you want to get a network spun up really quickly and you just want to run it, that backbone. And I'm just trying to think through my head places I've been where it's like, I really want to be able to get network up there. And that was a real pain to get cabling to.
Right.
And it would have been great if I could have shot something through that bit of the ceiling up to the floor above. Even if I could have got just 1 or 2 gig per second up there, that would have saved my bacon, kind of thing. So,
And by the way, there is a correlation between the speed and the link budget. So at lower speeds, you have more link margin, right? So you can through bigger, better attenuation. So if you want to shoot, say, if your main network is say 5 gigabits, but you want to shoot 1 gig off somewhere through a floor, the link budgets are higher, and so at that lower speed, so you can actually go through thicker material.
This might be a silly question, but each device is powered. Is it a standard 110 volt?
It's AC power 110 volt. Yes, it can also be powered by PoE, but we envision this to be primarily AC powered.
So not fully wireless. You still need the electrician to run the wire if you're hanging it from the ceiling.
That's right. So everything we've seen so far and talking to people in the industry, that is not a difficult problem to envision because there's mostly AC power running through these ceilings. And so we expect that this would have to be either tapped into an AC power line or connected to an outlet that's close by.
Yeah, it'll be AC power through an isolated, brick, if you will, that'll give us 12 or 48 volts, that's isolated from the wall outlet.
So it comes with its own AC brick?
Yeah, well, we would provide a brick in that case so that we could isolate it from the main power.
I was waiting for someone to ask for power over Ethernet. I was going to slap them.
Well, I mean, you think about it with the wireless access point, you're running a network cable. You're running a network cable, you're done. You have the power through that. Here, you're running a 110 volt outlet.
And there are implications to that too in terms of the cost of running high voltage rather than low voltage, right? But it's all relative. So
So what's, I've asked this with a few other things. What's the average buy-in on this? Like how much does the solution cost per unit to get in?
I think at the cost point that we're talking about, again, it depends on the use case. And some use cases are less cost sensitive than others. Some use cases are far more. But one use case we came across, for example, there's a desperate need to get bandwidth to kids in schools outside the community, in the communities, and there is very cost insensitive because you're comparing it to an almost impossible situation where you have to run fiber or cable through buildings that are incapable of being compliant with the codes once you do that. So in those scenarios, it tends to be somewhat less price sensitive, where you're directly competing with, where you're competing A and B, where both are feasible, then it becomes more price sensitive. So, we think that we did a computation based on a unit that cost between $800 and $1,000, and depending on the configuration, and compared putting a few of these units around to putting fiber, and we found that it was 1/3 to 1/7 the total cost of installing our system compared to installing a fiber backbone. So I don't know whether that answers your question, but we have a cost advantage in many different configurations, some significant cost advantage, some not so significant, depends on the configuration, depends on how challenging an environment it is to put fiber and cabling. If you're comparing it purely as a cost by apples for apples comparison, but in many cases, it's not an apples for apples because of the speed at which these need to be deployed and the speed at which they potentially need to be reconfigured. In those cases, we tend to be more price insensitive.
Okay, well, it gives me a ballpark. Thank you very much.
Right.
Is there a maximum size to the ring at the moment, or maximum number of hops that we can have?
No.
A maximum number of devices?
No, there is no maximum. As I said, I think we talked about this earlier, and I think the limiting factor there is if you have to go all the way around the ring in one direction, and the ring is a very long ring, then you could have latency issues. But other than the latency, there is no inherent maximum number of devices because each device only talks to the two neighboring devices. That's all it knows about. I mean, the software knows about the entire ring, of course, but the hardware only knows about the two neighboring devices. So there is no inherent limitation. Dave,
okay.
Yeah, that's
right. So, the other thing about this is that it is a difficult technical problem to solve, and we've been at it for quite a while. So we've been at it ever since 2017, doing a high degree of system work, system simulation, design. We have designed actually some chips already around this, although we're not deploying it in the first product. So we've done a lot of work in simulating the system to kind of finalizing the link budgets, ensuring that our product maintains a flat response as you do the beam steering, which is a key component of this. Ensuring that our antenna gains we can build antennas at these high gains. Ensuring that if you build the antennas with these high gains and have the right RF parameters, the system will work under different building materials. We've tested it. So it's a lot of difficult technology challenges to overcome. This is one of the reasons why people haven't tackled this problem. Of course, now these technologies are converging to the point where you have merchant silicon available that does this work. You can build these antennas, phaser antennas at low enough cost, but you couldn't do before because we have all kinds of new PCB materials that have emerged that are low cost. And so a lot of convergence of technologies have enabled this to happen. But because of our 3 years of work ahead of time, I think we're in a great position to tackle this problem and be the first out there with a product that actually works.
And the obverse of that question for a VC is what's the barrier to competition?
Well, we have 3 patents awarded that are the entire system patents, with 1 patent pending. The barrier to competition is it takes a while to get, we have a world-class team. It takes a while to get this right. It's not easy to do. So that's the time it takes to develop the product and develop the concepts and the system design is significant. And then now you take it one step further. When we do our next round of financing, we're going to actually design our own chips. And once you do that, it's all going to be it's going to be very difficult because those chips are going to be providing us much higher data rates, much lower costs, low power, very increased modulation, better modulation schemes, better forward error correction schemes. Once you design those chips, it's going to be tough to catch up with us.
Well, what'd you say, patent? You've already said enough that you own the design for that. No one else can just take it away. or else you can go after them, or try and license it at some point if you want to do that.
That's right. So we do own patents for the entire system design. So our patents cover all aspects of the system design, and including the whole FDD, the ring concept, even within the WaveTunnel, some of the technologies that are in there. So we've got them patented so that, yeah, it's going to be, people can't just duplicate what we do.
Yeah, at the top of my head, I think about this from a, something that either needs to be moved around or something that needs to be temporary. I think that's where it comes into play, because as you said, it sounds like something that you could bring up very quickly, as opposed to have to running network cables all over and getting a switch situated and all the connections, where you could get this up and running a lot quicker.
That's exactly right. We see that as one of the key value propositions, and I think it just throws up a plethora of use cases that previously would not even be able to tackle without that. So we are kind of excited about that as promoting that as a key value proposition. And in COVID year, actually the COVID era, we, while certain aspects of the network build outs become more challenging, and some industry sectors that previously would have been natural for us, such as large private venues and conferences and so on, where you need a lot of reconfiguration, would have been appropriate kind of early market segments for us. Now they are not, because COVID has reduced their business. However, there are several other opportunities thrown up by COVID that will be also natural for us that we're now exploring, and certainly the ability to get bandwidth to places that previously did not have it and do it quickly becomes a key value proposition. And we're going to be exploiting those and trying to get into the market with those particular use cases. And we would like to welcome all of you as you come across a particular use case in your daily experience, or of one, or even if you don't have it now, as you come across one, please reach out to us. We're looking for feedback and help in this area in terms of identifying use cases where the pain points are high enough where we can get into the market quickly and add value.